All right, let's take a look at number problem 657. First thing you have to do is get that balanced chemical equation. To save time, I just went ahead and told it to show you the answer. Once you have that balanced chemical equation, you're prepared to do the stoichiometry, which may or may not be what's confusing you. How many grams of oxygen are required to react with 0.122 grams of lead-2 sulfide? So they're telling you that you have 0.122 grams of lead-2 sulfide. You don't want grams of lead-2 sulfide, so you're going to place those grams of lead-2 sulfide where they cancel out. Like in the first chapter, you don't want to think if you can help it. Whatever unit you have here, you automatically want to go down here. Now, the only thing you ever know in chemistry about grams is molar mass. So you're going to go to your periodic table, and you're going to discover that lead has a molar mass of 207.2, and sulfur has a mass of 32.0. So we've got 239.2 grams for our molar mass. So 239.2 grams in 1 mole of lead sulfide. And we've canceled out grams. So we've gone from grams of lead sulfide to moles of lead sulfide. Now I don't want moles of lead sulfide, so I'm going to place my moles of lead sulfide where they'd cancel out. I'm being asked about grams of oxygen. Do I know a relationship between moles of lead-2 sulfide and moles of oxygen? Yeah, that chemical equation right there tells me. It tells me that 2 moles of lead sulfide is needed to react with 3 moles of oxygen. I'm just going to keep those numbers with the molar masses. 2 moles lead-2 sulfide, 3 moles of oxygen. I have moles of oxygen now. So I'm going to place moles of oxygen where they cancel out. Now, molecular oxygen, O2, contains 2 moles of atomic oxygen, each of which have a mass of 16 grams. So 2 times 16 is 32. So 1 mole of oxygen has a mass of 32 grams. So I'm going to have grams of oxygen, which is what I'm looking for. So I'm going to multiply everything on top, divide by everything on the bottom. So I'm taking 0.122 divided by 239.2 times 3, divide by 2 times 32, and that gives me a mass of 0.0245 grams of oxygen. So that's my grams of oxygen. And C and D are going to be worked basically the same way, except you're going to be starting with different substances. So that's that for that one.